Okay, so today I will talk about the solution of a second order differential equation with constant coefficients. In the earlier lecture I talked about this that I have considered a simple pendulum, and I have generated second order differential equation and tried to find out its solution. So now I will talk about second order differential equation. So let us consider a second order differential equation, say general. So a d square y over dx square plus v dy over dx plus c y is equal to 0. So it is a second order differential equation, and here a, b, c, these are the constants. So if I try to find out its solution, let us do one thing. Let us recall a function e raised to power alpha x. It's an exponential function, and it's a very interesting function. Means if I take derivative of this function e raised to power alpha x with respect to, and its derivative e raised to power alpha x, and if I again take its derivative, then means if I take derivative of this alpha e raised to power alpha x, then it's again comes out to be alpha square e raised to power alpha x, and so on. Means the actual form of the function will remain intact. Similarly, if I take its integral, say e raised to power alpha x is the function, if I take its integral, it's again e raised to power alpha x over x. It will remain as it is, right? So that means original form of the function will remain in that form, multiplied by the certain constants in any form. So let us assume that let us consider that y is equal to, let us consider that y is equal to e raised to power alpha x. It's an exponential function, and let it be solution of given differential equation. And if I assuming that this is the solution of this given equation, that means it must satisfy this equation, right? I'm just assuming, and but should be the form of this, that we will discuss it later on. So I just putting this value here, so it is a d square e raised to power alpha x over dx square plus b d e raised to power alpha x over dx plus c y, sorry, y is not there, but it is e raised to power alpha x, and it is equal to 0. And let us do little more algebra. So if I recall here, as I know that dy over dx is this one, and if I take its second order derivative, means if I try to find out d square e raised to power alpha x over dx square, and it can be written as d upon dx of d e raised to power alpha x over dx, right? And its value is nothing but its value is alpha e raised to power alpha x, and if I again take its derivative, alpha can be taken outside, and this alpha is also with it, so it is alpha square d upon it is e raised to power alpha x. So that's the solution. Let us substitute all these values. Means one value is here and another value is here, and the value of y will be here. Let us put here. So I can write down this equation as a alpha square e raised to power alpha x plus b alpha e raised to power alpha x plus c e raised to power alpha x, and it is equal to 0. Say this term is common in all, so it can be taken outside. So that means inside it will remain a alpha square b alpha plus c, and inside, outside it e raised to power alpha x. It's equal to 0. So now these are the two factors. This is one factor and this is another factor. So product of two factors will be 0. It is possible if either first factor is 0 or second factor is 0, or both the factors are 0. But if I have a look at it, so in this there is a one factor e raised to power alpha, and it can never be 0. If this factor can never be 0, then this factor must be 0. So therefore I can write down it a alpha square b alpha plus c is equal to 0. So as I know a earlier equation that ax square plus bx plus c, then this is a quadratic in x. Similarly, this equation is quadratic in alpha, means this equation is quadratic in alpha. So that means alpha can be written as a minus b plus minus b square minus 4ac over 2a. So let me go back. So that means the equation will be like this: a alpha square plus b alpha plus c equal to 0, and alpha can be written as minus b plus minus b square minus 4ac whole under the root upon 2a. So that means there are two possible solutions, alpha 1 and alpha 2. So one value is minus b plus b square minus 4ac under the root over 2a. Similarly, alpha 2 can be written as minus b square minus 4ac under the root upon 2a. So these are the two possible values, but here this term is little bit more tricky. B square minus 4ac. How? Let us have a look at this. So if b square minus 4ac is greater than 0, then the roots are, means the values of alpha 1 and alpha 2 are real and distinct. This is the case 1, and another case is the case 2. Then b square minus 4ac, it is equal to 0. Then alpha 1 and alpha 2 are real and equal, means alpha 1 is equal to alpha 2. The second case. And case 3 will be that b square minus 4ac is less than 0. If it is negative, then the roots are imaginary, the complex roots, means alpha 1 and alpha 2 are complex and complex conjugate, and complex conjugate to each other, means if alpha 1 star is equal to alpha 2, that's the meaning of this one. So let us have a look at the solutions. So that means if this is the first case, then the roots are real and distinct and obvious. So then I can write down for the given equation. Let me first of all consider the case number 1. For the case number 1, means when the roots are alpha 1 and alpha 2 are real and distinct, then in that case what should I do? That there are two possible solutions. y1 is the one possible solution. It can be written as e raised to power alpha 1x, and y2 is the, because we have assumed that the y is equal to alpha 1x is y is equal to e raised to power alpha x is the solution of this equation, but alpha has the two values, alpha 1 and alpha 2. That means it has two possible solutions. y1 is equal to e raised to power alpha 1x, and the another solution is e raised to power alpha 2x. These are the two possible solutions. Then general solution must contain these two solutions. So therefore general solution must be linear combination of y1 and y2. So therefore I can write down y is equal to, and y is basically a function of x, so it can be written as c1 e raised to power alpha 1 x and c2 e raised to power alpha 2 x. So this is the first solution when the roots are real and distinct, and we can prove it also. Means if these two are the possible solutions of the given differential equation, and then their linear combination is also solution of that equation. Now let me go back to the next case. For the next case 2, so if alpha 1 and alpha 2 are the real and distinct, that means alpha 1 is equal to alpha 2. In that case, the alpha 1 basically, in this case, because this part is 0, so from here I can write down alpha 1 is equal to alpha 2, and both are equal to minus b upon 2a. This is the solution. So then first solution is equal to e raised to power alpha x. It is the solution of the given equation, and let us call it as alpha because both are equal. And similarly y2 is equal to x into e raised to power alpha x is also solution of the given differential equation. This is the case, and we can prove it separately if you want to prove. So but it is the possible when there is a repeated root, right? So what do I do? It is basically, so general solution is basically linear combination of these two. So means general solution is basically linear combination of these two possible solutions. So that means that y is equal to, which is a function of x, it can be written as c1 e raised to power alpha x plus c2 x e raised to power alpha x. So this can be written as c1 plus c2x and e raised to power alpha x. So this is the solution of the given equation. It can be written in this way. Now let me come back to the the third case. And what is the third case? This is the case 3. And what is there in it? In the case 3, so let me write it down as that alpha is equal to minus b upon 2a plus minus b square minus 4ac under the root. But b square minus 4ac is a negative value. It is basically a negative value. So that means it can be written as minus b upon 2a plus minus iota can be taken outside, so that's why it will become positive. And or in other words, what should I do? Let me redo a few things. So because it is a negative value, so let us call it as iota q and let us call it as p. So it can be written as p plus minus iota q, right? So that means it must have two possible solutions, and both are complex conjugate to each other. Means if alpha 1 is p plus iota q, then alpha 2 can be written as p minus iota q. This is the solution. So therefore the solution can be written as that y1 is equal to e raised to power alpha 1 x. So it can be written as e raised to power p plus iota q x. Similarly, y2 can be written as e raised to power alpha 2x, and it is equal to e raised to power p minus iota q x. So therefore general solution is basically linear combination of these two. So it can be written as c1 e raised to power p plus iota q x and plus c2 e raised to power p minus iota q x, and it can be further simplified. So let me try to simplify this. So it is c1 e raised to power p e raised to power plus iota qx, it is px, plus c2 e raised to power px e raised to power minus iota qx. So this part is a common, this part is common, this part is common, so it can be written as c1 e raised to power iota qx plus c2 e raised to power iota qx with the negative sign, and it is multiplied by e raised to power px. And if I have a look at it, then this is exponentially growing, and this is basically when iota is sitting with the exponential function, then it is a plane wave like function. So that means this part is basically, if I have a look at it, this part is basically like this, and this part is basically exponentially growing function. So that means if it is this is the solution, then the solution of the wave function must be like this, means exponentially growing function. Means amplitude is this and amplitude is this and exponentially it is. So amplitude of the wave is exponentially growing like this. Sorry, this must just yeah. So if it is exponentially growing function, say if it is growing like this, so that means its solution of such a wave function is can be written like this. It's like this. So it is exponentially growing function. It is the solution of such type of equation. But if minus q p is sitting here in rather than this, means if p is negative, then the solution is like this. So it is exponentially decaying amplitude. This type of solution we get the in case of damped harmonic oscillator, right? So thus I talked about briefly that how solution is coming out, and if I recall all the results of these, that means the first solution is y is equal to c1 e raised to power alpha 1x and e raised to power alpha 2x and multiplied by c2. Just a minute, let me recall. Yeah, c2 e raised to power alpha 2x, and another possible solution is c1 plus x c2 and e raised to power alpha x, and another solution is basically it is c1 e raised to power c1 e raised to power plus iota qx plus c2 e raised to power minus iota qx and whole multiplied by e raised to power px, right? So these are the possible solutions, means the combination of the exponential and periodic functions. Means when exponential containing iota, that means it is a periodic function. But if iota is not sitting with the exponential function, that it is a exponentially growing or the decaying function, depending upon what type of value is this p. Or here what type of value is the alpha 1 and alpha 2, whether it is positive or negative. If it is positive, then it is exponentially growing function, and if it is negative, then it is exponentially decaying function. So how those functions looks like, we must have a certain idea about that. Say it is x-axis, so say x is this one, so its plot is like this. This function is exponentially growing, so it is e raised to power alpha x. But if alpha is negative, then its function is like this. Just let me change the color. Yeah, then this solution is basically e raised to power minus alpha x view, right? This is basically this one. And if certain function is multiplied with the, say it is a periodic function, and these are the periodic function, and their plot is like this. It's a sinusoidal wave. Alright, you have to recall all these things. These are the basic things which we have to keep in mind. So this is all for solution of second order differential equation, homogeneous differential equation with constant coefficients.